Hello guys, welcome. We will be delving into fascinating experiment, speed measurement using photoelectric pickup, also known as optocoupler. In this video, we will first start with the introduction, equipment overview, theory behind the experiment, procedure where I will be demonstrating the how to perform the experiment, and finally the results. Introduction. This experiment basically aims to study the performance of optocoupler using oscilloscope as well as the speed counter. Basically, we will be comparing the values of digital RPM display with oscilloscope as well as the speed counter. Equipment overview. The main component of this experiment is the trainer kit, where the signals from the optocoupler is processed and given as RPM display and signals to oscilloscope by wave shaper. Basically, the optocoupler wave shaper helps in shaping the output waveform to measure specific requirements like amplitude, frequency, and duty cycle, which helps in analyzing the performance of the optocoupler. Multiplier multiplies the frequency by 4 times. You can ask why 4 times. See, the wave shaper gives waves in seconds, that is let's say x seconds for 1 revolution, which has 15 slots in a disk. So 15 slots is equal to 1 revolution, so x seconds, which corresponds to 1 by x frequency. For 1 rpm, it will be 15 by 60, whose reciprocal is 4. So hence it's a 4 times multiplier. And here we use up counter. Upon holding the button, it counts the number of times the slot encountered the optocoupler. 1 Hz clock is used as a reference. The cathode ray oscilloscope CRO helps in observing and analyzing the waveforms of the signals from wave shaper. The optocoupler, the main component, consists of an LED on one side and a photo detector on the other side, separated by slots of the disc. So whenever the slots encountered between the couple, there won't be any signal sent, that is 0, and 1 when there is no slot between them, and the photo detector detects the light sent by the LED. So what's the theory behind this experiment? The theory of optocoupler and oscilloscope is covered in the equipment overview itself. Here you can find the formula for calculating the RPM in the speed counter method. Yes, there is a pro tip while performing this experiment. If we keep 4 seconds as the timer for calculating the speed counter, it gives the count which is almost close to the RPM display value. Yeah, as you can see, 7.8 divided by 4 is equal to 85 by 60. So this is a trick you can use for performing the experiment, which helps you to compare the count easily without actually counting it, calculating it. So let's go for the experimental procedure. This is our trainer kit having a power supply control to the motor, RPM, counter switch with push count and reset button. To analyze multiplied signal, we need to connect here. Here is the voltmeter displaying the voltage given to the motor. The CRO provides the waveform generated by the optocoupler. For readings, we change the voltage and record the RPM corresponding to that voltage, and the frequency of waveform from wave shaper, and the frequency of multiplier, which is almost equal to the display of the RPM. We shift to speed counter method. We reset it, and before we start, we will have the timer of 4 seconds as explained before. The counter values closely matches with the display RPM, and we calculate the absolute error. So here are the readings we recorded, and we have got this much absolute error with oscilloscope, and here is for speed counter. And we have found a linear relationship between the speed counter value and the oscilloscope readings, saying that our trainer is working perfectly. So here comes the important part, precautions. Knowing precautions before performing an experiment is always a good practice. Don't run motor beyond 3 voltage. Check all connections are perfect and correct, and make sure there is no external disturbance which gets captured by the uh, photo detector. And that concludes our experiment. Thanks for watching this video. If you find this video helpful and good, please like, share and subscribe.